This time, let us have examples for matrix multiplication. So, we're given two sets of matrices A and B. So, find, if possible, AB and BA. Pause the video and try to see if you'll be able to perform these given operations. Alright, so first let's do number 1. 1A, AB. So we were try to see if we can find this product. Take note that we have to double check whether or not it's actually possible to perform the matrix multiplication by comparing the sizes of our matrices. So, A is 2 by 2 and B is also 2 by 2. Since the column of the first matrix matches or has the same number of rows, then we can have this one. Therefore, we will result to another 2 by 2 matrix. So, we're now going to multiply 1, 2, 4, 2, 2, 2, negative 1, negative 1, and 8. So, let's just bring that down. So, to perform this, we need to follow our pattern. We first multiply 1 and 2. So, that will be 1 times 2. Then, 2 times negative 1. We need to add that. And this becomes our first row 1, column 1 entry. Then for our A sub 2 entry, we're now going to have 1 times negative 1. So 1 times negative 1. Add that to 2 times 8. 2 times 8. Then for A sub 1, 2, A sub 2, 1 rather, A sub 2, 1 rather, we would be needing to have 4 times 2. So let's have that 4 times 2. Then 2 times negative 1. So we'll add that 2 times negative 1. So for entry sub 2, A sub 2, we're going now to have 4 times negative 1. So 4 times negative 1 and add 2 times 8. And simplifying these expressions, we're going to have 0, 5, 6, and 12. So therefore, the product of AB would be equal to the matrix having the elements 0, 5, 6, and 12. Let's now look into BA. So letter B, BA. So since we already determined that both are 2 by 2, once we would have that sum, it would still be 2 by 2. So therefore, we can already proceed. So first, let's have matrix B, 2, negative 1, negative 1, 8, multiply 2, 1, 2, 4, and 2. So following the same pattern that we just did, first we multiply 2 and 1. So that would be 2 times 1. Add that to the product of negative 1 and 4. So we'll have negative 1 times 4. For entry A sub 1, 1. For A sub 1, 2, we're now going to have 2 times 2. So we'll have 2 times 2. Add that to negative 1 times 2. Negative 1 times 2. So there you go. And then, after which, we're going to have now entry A sub 2, 1. Negative 1 times 1. So we'll have that negative 1 times 1. Add that to 8 times 4. So let's write that 8 times 4. Finally, for a sub 2 to here, we're going to have negative 1 times 2. So we'll have negative 1 times 2. Add that to 8 times 2. So we'll have 8 times 2. So therefore, finalizing all these expressions, we're going to have negative 2, 2, 31, and 14. So therefore, B times A results to the matrix negative 2, 2, 31, and 14. There you go. Now let's look at the other item. So, for number 2, oops, there you go. A is given by a 3 by 3 matrix. Let's fix that so that we can properly write. A is equal to a 3 by 3 matrix. 1, negative 1, 7. 2, negative 1, 8. 3, 1, negative 1. B is equal to 1, 1, 2. 2, 1, 1, 1, negative 3, 2 here. So first, let's look for AB. So we'll write AB here. There you go. So this will actually be resulting to 1, negative 1, 7, 2, negative 1, 8, 3, 1, negative 1, side by side with 1, 1, 2, 2, 1, 1, 1, negative 3, 2. And this will be a longer process as we're going to look into a 3 by 3. Since both of them are 3 by 3 matrices, the product will also be a 3 by 3 matrix. So, going down here, there you go. So first, we would need to get the product of 1 times 1. So let's get that. 1 times 1. The negative 1 times 2, we need to add that. Negative 1 times 2. And then we would be getting 7 times 1. So we'll have plus 7 times 1. Now, it will be a very long process, so let's put up the numbers already. So I am going to show the one for entry A sub 1, 2, and then we're going to skip it so that we're going to see now all the numbers because it will take quite a long time. So for row sub 1, 2, let me just adjust this one here. There you go. For A sub 1, 2, that entry, we're going to have the following. So we're going to have 1 times 1 here. So let's have that. 1 times 1. Added 2. We're now going to have negative 1 times 1. So we'll have negative 1 times 1. Added 2. 7 times negative 3. So therefore, we'll have times 7 times negative 3. Then, let's now put all the other entries. Alright, it was quite long, so here we have already placed all the possible entries. And now, simplifying all of them, we're going to get the following entries. So we're going to have here 6, then negative 21, then 15, then 8, then negative 23, then 19, 4, 7, and 5. So therefore, the product AB is equal to that matrix. 6, negative 21, 15, 8, negative 20, 23. Wait a moment, let's fix that. Negative 23, 19, 4, 7, and 5. Now, let's do the same for BA. So let's just have that a bit. There you go. So for BA, it will simply be 1, 1, 2, our B multiplied by our matrix A. There you go. So we are now going to place how we multiply our entries, and it's very similar to what we just did just a while ago. But to make it fast, we're going to place already everything. There you go. We have placed everything because that will take quite a while. And as we can see here, if we're just going to point out, it will still be 1 times 1 here, 1 times 2, 2 times 3, and so on. So, finalizing or simplifying rather, these values, we're going to have the following matrix. So we're going to have 9, 0, 13, 7, negative 2, 21. Let's fix that 2. There you go. And then 1, 4, negative 19. So therefore, BA is equal to this matrix that we will just rewrite. 9, 0, 13, 7, negative 2, 21, 1, 4, negative 19. And those are examples of matrix multiplication.